We're living in the golden age of robotics. While Tesla pushes boundaries with Optimus, Boston Dynamics amazes us with Atlas, and Figure AI makes headlines with their humanoid breakthroughs, a European company just stepped onto the world stage and completely changed the conversation. At Automatica 2025 in Munich, Neura Robotics didn't just unveil another robot prototype, they revealed what might be the most deployment-ready, commercially viable humanoid robot we've ever seen. The 4NE1 Gen 3 isn't just competing with the big names anymore, it's setting a new standard entirely. Neura Robotics has been quietly building something extraordinary while the world focused on Silicon Valley headlines. Based in Germany, this company understood something that many others missed: the gap between impressive demonstrations and actual industrial deployment. While competitors focused on viral moments and jaw-dropping stunts, Neura concentrated on creating a robot that businesses could actually use tomorrow. The 4NE1 Gen 3 represents 3 years of intensive development, real-world testing, and industrial feedback. This isn't their first humanoid robot, but it's their first robot designed specifically for mass deployment. The previous generations proved the concept. Gen 3 proves the execution. The first thing that strikes you about the 4NE1 Gen 3 is how deliberately it's been engineered. Standing at 180 centimeters tall and weighing 80 kilograms, it's built to human proportions for a reason. It needs to work in spaces designed for people, not robots. This isn't about making robots look human for aesthetic appeal. It's about practical integration into existing workflows and infrastructure. The robot's design language is distinctly industrial. Clean lines, durable materials, and accessible components all point to one thing: this machine was built to work every single day in demanding environments. The aesthetic choices aren't about impressing consumers at a tech conference. They're about surviving years of continuous operation in warehouses, manufacturing floors, and service environments. But the real breakthrough isn't in how it looks, it's in how it thinks. The robot features 360 degrees vision powered by 7 integrated cameras, natural language understanding, artificial skin that mimics human touch, and force-talkie sensors that can detect and adapt to applied pressure. This isn't just sensor fusion, it's sensory intelligence that approaches human-level environmental awareness. The specifications tell a story of serious engineering. The 4NE1 features an intelligent dual battery system for uninterrupted 24/7 operation and can lift up to 220 pounds thanks to powerful joint technology. That lifting capacity isn't just impressive, it's transformative for industries where heavy manual labour is still the norm. The hands deserve special attention. These are fine motor, learning-capable hands that can adapt to different tasks without requiring complete reprogramming. The robot is designed to handle tasks such as ironing, unloading the dishwasher, and carrying heavy objects, showcasing a versatility that spans from delicate household chores to industrial, heavy lifting. What's revolutionary about the Gen 3 is its cognitive architecture. This isn't traditional robotics where every motion is pre-programmed. The robot can understand complex instructions, adapt to changing conditions, and learn from experience. It navigates unstructured industrial environments, understands complex tasks, and responds to changing conditions in real time. Now, before we get into the connection of Nvidia with this robotic marvel, if you are interested in learning about 2025's 2 of the best robotic marvels, make sure to watch the video shown on your screen. One of the most significant aspects of the 4NE1 Gen 3 is its technological foundation. The robot is powered by Gruton 1 and was trained in Isaac Sim and Isaac Lab before real-world deployment. This partnership with Nvidia represents a fundamental shift in how humanoid robots are developed and trained. Traditional robot development required building physical prototypes and testing them in real environments, a slow, expensive, and limited process. With Nvidia's simulation platforms, the 4NE1 Gen 3 was able to experience millions of hours of virtual training before its first real-world deployment. It learned to handle countless scenarios, edge cases, and failure modes in simulation, making it far more capable and reliable in actual operation. This simulation-first approach also enables continuous learning. As new challenges are identified in the field, they can be replicated in simulation, solved virtually, and the solutions can be deployed to all robots in the fleet. It's like having a global brain that learns from every robot's experience and shares that knowledge instantly. Neura didn't just build a robot, they built an entire ecosystem. Neura Robotics is presenting Neuraverse, a digital twin and interconnected ecosystem for robot training, skills and applications fully compatible with Nvidia Omniverse technologies. This represents a fundamental shift from selling robots to selling robotic intelligence as a service. The Neuraverse ecosystem means that buying a 4NE1 Gen 3 isn't just purchasing hardware, it's gaining access to a constantly evolving library of skills, applications, and capabilities. As new tasks are developed and tested, they can be deployed to existing robots in the field. A robot that starts by handling warehouse logistics could later learn to perform quality control, customer service, or facility maintenance. This ecosystem approach also enables multi-robot coordination. Instead of individual robots working in isolation, the entire fleet can operate as a coordinated network. One robot's experience becomes everyone's knowledge. Efficiency improvements discovered at one facility can be automatically deployed across all installations. The demonstrations at Automatica 2025 weren't just impressive, they were practical. The 4NE1 Gen 3 showed its ability to work in unstructured environments, handle irregularly shaped objects, and adapt to changing conditions without human intervention. These aren't parlor tricks, they're the fundamental capabilities needed for real-world deployment. In industrial settings, it's expected to move freely in unstructured environments and adapt to changes in real time. This adaptability is crucial because real workplaces aren't like controlled laboratory environments. Items get moved, layouts change, and unexpected obstacles appear constantly. Traditional automation breaks down in these conditions. The 4NE1 Gen 3 thrives in them. The household applications are equally significant. A robot that can iron clothes, load dishwashers, and handle delicate objects represents a major breakthrough in service robotics. These tasks require fine motor control, environmental awareness, and the ability to work safely around humans. Exactly the capabilities that have made household robotics so challenging until now. The unveiling of the 4NE1 Gen 3 represents a significant shift in the global robotics landscape. While American companies like Tesla and Figure AI have dominated headlines, Neura's European approach offers something different. Engineering maturity over marketing spectacle. Practical deployment over viral demonstrations. This matters because the robotics industry is reaching an inflection point. The fundamental technologies, artificial intelligence, computer vision, advanced materials, and precision manufacturing have all matured to the point where truly capable humanoid robots are possible. The question now isn't whether these robots can be built, but who can build them at scale and deploy them successfully. Neura's focus on industrial applications and business practicality positions them perfectly for this transition. While other companies chase consumer markets or research headlines, Neura is targeting the immediate need for labor automation in industries facing severe worker shortages and increasing operational demands. The success of the 4NE1 Gen 3 also highlights broader trends in robotics and artificial intelligence. The integration of large language models, computer vision systems, and robotic control represents the convergence of previously separate technological domains. Modern robots aren't just mechanical systems with computer controls, they're embodied artificial intelligence systems that can perceive, reason, plan, and act in the physical world. This convergence is accelerating rapidly. The same AI systems that power language models and image recognition are now being adapted for robotic applications. The same simulation technologies used for autonomous vehicles are being applied to humanoid robots. The same manufacturing processes that produce smartphones and electric vehicles are being adapted for robot production. One of the most impressive aspects of Neura's announcement is their manufacturing roadmap. This isn't a research project or concept demonstration, it's a commercial product with clear production plans. The company has been transparent about their scaling ambitions and their partnerships with manufacturing suppliers. The dual battery system exemplifies this production-ready thinking. Instead of requiring robots to stop working for charging, the hot-swappable battery design enables continuous operation. This isn't just a technical feature, it's a business requirement for industrial deployment. Downtime costs money, and customers need robots that can work as continuously as the human workers they're replacing. The modular design philosophy extends throughout the system. Components can be replaced, upgraded, or customized without requiring entirely new robots. This reduces long-term costs and extends the useful life of each unit. Critical factors for industrial customers making major capital investments. The implications extend far beyond robotics. As humanoid robots become practical and affordable, they'll accelerate automation across industries that have resisted it until now. Service sectors. Small manufacturing, healthcare, and domestic applications all become viable markets when robots can work safely and effectively alongside humans. What happened at Automatica 2025 wasn't just a product reveal, it was a glimpse into a future where advanced robotics are practical, affordable, and transformative. The 4NE1 Gen 3 proves that this future isn't decades away. It's happening right now, and it's more impressive than anyone expected. In the heart of Paris, at VivaTech recently, a moment unfolded that left the world's tech community buzzing. Among the dazzling displays of electric cars, lifelike androids, and next-generation AI, one creation stood head and shoulders above the rest: Darwin, the French-made AI robot that just redefined what we expect from robotics. Let's dive into how Darwin has broken away from the pack, outshining even the most hyped robots like Tesla's Optimus and Unitree's Gen 3, and why its debut at VivaTech 2025 is a turning point for the industry. What makes Darwin so different? For years, robots have been getting more agile, more expressive, and a little smarter with every upgrade. But Darwin didn't just get a new coat of paint or a slightly better processor. It's the first AI robot to combine self-charging, self-swapping batteries, full autonomy, and seamless integration with factory systems, all in a single factory-ready package. While earlier robots could run for a few hours, Darwin is designed to work around the clock. When its battery runs low, it doesn't wait for a human to plug it in. Instead, it rolls itself to a charging dock, or in its most advanced version, swaps its own battery in seconds using a built-in drawer system. This means Darwin can work 12 hours straight, 8 hours of heavy lifting on the factory floor, followed by 4 more hours of quality checks without breaking a sweat. And here's what really sets Darwin apart. It can plug directly into the same software that runs other machines in a factory, like manufacturing execution systems and warehouse management platforms. That means it doesn't just work in isolation, it becomes a fully integrated part of the team, able to coordinate with other robots and systems in real time. Darwin's journey didn't happen overnight. Previous versions were impressive, but often limited to either wheeled or bipedal movement, with short battery life and basic task execution. The new Darwin, however, is a leap forward. Omni-directional wheels allow it to glide smoothly in any direction, making it perfect for tight factory aisles. 28 high-torque motors give it strength and precision, whether it's lifting heavy objects or handling delicate components. Radar and LiDAR fusion means Darwin can map its surroundings in real time, avoiding obstacles and navigating complex spaces without human guidance. Remote operation is possible via ultra-fast 5G networks, so a human can take over instantly for tasks that need extra finesse. But perhaps the most jaw-dropping feature is Darwin's immortality. Thanks to the self-charging and battery swapping system, it can theoretically run forever, only stopping for scheduled maintenance. But if you think only France has stepped up to match the level of AI robotic development, then you might be wrong, as Germany is also gearing up. Make sure to watch the German robot that is challenging global bests. Coming back, Darwin isn't just a showpiece, it's already working in real factories, moving items, switching tools, and even collaborating with other robots. Here's a glimpse of what it can do. Autonomous navigation. Darwin moves through warehouses, avoiding people and obstacles, and can even find its own charging station. Tool swapping. Need to switch from a gripper to a screwdriver? Darwin does it on the fly, without human help. Teamwork. Multiple Darwins can coordinate, passing items between each other or working together on complex tasks. Remote control. If needed, a human operator can don a VR headset and take direct control with almost zero lag for precision work. This is not just a robot that follows scripts. Darwin learns from its environment, adapts to new tasks, and can be updated over the air with new skills. Let's put Darwin side by side with its main rivals, Tesla Optimus and Unitree Gen 3. Tesla Optimus. Tesla's Optimus has made headlines for its human-like form and dexterity. The latest version boasts full autonomy in navigation and object manipulation, human-like hands with 22 degrees of freedom, allowing for precise tasks like soldering wires or picking up delicate objects, self-learning AI that can watch humans and learn new tasks by observation, integration with Tesla's self-driving tech, using advanced sensors and neural networks. But while Optimus is impressive, it's still largely in the prototype stage, with limited real-world deployment. Battery life is improving, but it still requires downtime for charging, and its integration with factory systems is less seamless than Darwin's. Unitree Gen 3. Unitree's Gen 3 is all about agility and speed, 43 joint motors for incredible flexibility and balance, walking speed of 12 kilometers per h, making it one of the fastest humanoid robots, force position hybrid control for precise object handling, advanced sensors for 360-degree awareness and rapid learning. Unitree claims it can master walking in just 2 days. Unitree's Gen 3 is already being used in healthcare and warehouses, but its battery life is around 2 hours, and it doesn't have the same self-charging or battery swapping capabilities as Darwin. It's agile, but not designed for continuous heavy-duty work. Why Darwin is different. What truly sets Darwin apart from the crowd and makes it a genuine game-changer in the world of robotics. It's a combination of groundbreaking features and practical design choices that together create an unprecedented level of autonomy, versatility, and real-world usability. First and foremost, Darwin's endless operation capability is revolutionary. Unlike most robots that require frequent downtime to recharge their batteries, Darwin is designed to be completely self-sufficient. It can autonomously navigate to charging stations or even swap its own battery packs without any human intervention. This means Darwin can operate continuously, around the clock, without the usual interruptions that limit productivity. This feature alone earns it the nickname of the first immortal factory robot, capable of maintaining relentless work cycles that dramatically boost efficiency and reduce operational costs. Another standout feature is Darwin's seamless integration with existing factory management systems. Many robots struggle to fit smoothly into complex industrial environments because they require specialized infrastructure or extensive reprogramming. Darwin, however, is built to plug directly into the software ecosystems that factories already use, such as manufacturing execution systems and warehouse management platforms. This makes deploying Darwin fast, efficient, and cost-effective, allowing companies to upgrade their operations without disrupting workflows or retraining staff extensively. Beyond integration, Darwin's real-world deployment status is a critical differentiator. Unlike many robots that remain confined to labs or limited pilot programs, Darwin is already actively working in factories, warehouses, and production lines. This proven track record means it's not just a concept or prototype. It's a reliable, battle-tested machine delivering tangible results every day. Darwin's adaptability is another key strength. It's not limited to a single task or environment. Whether it's moving heavy materials, switching tools on the fly, or collaborating with other robots and human workers, Darwin excels across a wide range of applications. This versatility makes it a valuable asset in dynamic industrial settings where demands can change rapidly. Finally, Darwin offers both remote and autonomous operation modes. It can work fully independently, making decisions and navigating complex spaces on its own. But when precision or human judgment is needed, operators can take control remotely via ultra-low latency connections, ensuring flexibility and safety. In essence, Darwin isn't just another robot. It's a new breed of intelligent, self-sufficient, and highly adaptable machine designed to revolutionize how industries operate. One of the most exciting aspects of Darwin is its ability to work alongside humans. It's not here to replace workers, but to take on the repetitive, dangerous, or physically demanding tasks, freeing people to focus on more creative and rewarding work. Imagine a warehouse where Darwin handles the heavy lifting, navigates tight spaces, and keeps the workflow moving smoothly. Or a factory where it switches tools and adapts to new tasks on the fly, all while coordinating with other robots and human workers. This is the future of work. Not robots replacing people, but humans and machines working together, each doing what they do best. Darwin's debut at VivaTech 2025 isn't just about one robot. It's a signal that the age of intelligent, autonomous, and truly useful robots has arrived. With its endless operation, seamless integration, and real-world deployment, Darwin is setting a new standard. The competition is fierce, and robots like Tesla Optimus and Unitary Gen 3 are pushing the boundaries of what's possible. But Darwin's unique combination of features, especially its self-sufficiency and factory integration, puts it in a league of its own. As more factories, warehouses, and even public spaces adopt robots like Darwin, we're entering a world where intelligent machines are not just tools, but partners. They'll help us build, create, and solve problems in ways we've only dreamed of. The story doesn't end here. The team behind Darwin is already working on new upgrades, better AI, more advanced sensors, and even greater autonomy. The goal? To make robots that are not just helpers but collaborators, capable of learning, adapting, and even anticipating our needs. And as other companies race to catch up, we can expect a wave of innovation that will make robots faster, smarter, and more human-friendly than ever before. So the next time you see a robot rolling through a factory or gliding down a warehouse aisle, remember, the future arrived in Paris at VivaTech 2025 with a French-made robot named Darwin that shocked the world and changed it forever. A paralyzed man named Alex sits in his wheelchair. He hasn't moved his arms in years, but right now he's playing rock, paper, scissors with a robotic hand. Not with a remote control, not with buttons, with his mind. The robotic hand moves exactly like he thinks it should. Each finger curls when he wants it to. And here's the crazy part. That robotic hand isn't just some medical device. It's part of Tesla's Optimus robot. The same robot Elon Musk wants to put in every home and factory on Earth. This isn't just another tech demo. This is the moment when human brains and robot bodies became one. And it changes everything we thought we knew about the future. Just a few months ago, Elon Musk dropped shockwaves through the robotics world. Anyone with a Neuralink chip can now control a Tesla Optimus robot using only their thoughts. Not their voice, not their hands, just their mind. Let that sink in for a moment. A person can think about moving an arm, and somewhere else in the world, a robot arm moves exactly like they imagined. They can think about walking, and a robot walks. They can think about picking up a cup, and robotic fingers wrap around it perfectly. But this isn't the talks of future anymore, it's happening right now. The proof came from Alex, a patient who suffered a spinal cord injury. Before Neuralink, he couldn't write or draw. Those abilities were just gone. But now, with a tiny chip in his brain connected to robotic hardware, he can control a robotic hand in real time. Every finger movement comes directly from his thoughts. The wild part, this robotic hand is actually a prototype from Tesla's Optimus robot. The same humanoid robot that Elon Musk plans to mass produce for homes, offices, and factories worldwide. Alex isn't just controlling a medical device, he's controlling the future of robotics with his mind. The science behind this breakthrough sounds like magic, but it's surprisingly simple. Neuralink's chip reads tiny electrical signals from the brain. These are the same signals that normally tell your muscles to move, but instead of going to paralyzed muscles, they go to a computer. The computer translates these brain signals into commands that a robot can understand. When Alex thinks about curling his finger, his brain creates specific patterns of electrical activity. Neuralink captures these patterns, decodes them instantly, and sends the commands to robotic fingers. There's no delay, no lag time. It's as smooth and natural as moving your own hand. The only difference is that the hand isn't made of flesh and bone. It's made of metal and motors. But Optimus takes this to a whole new level. It's not just a hand, it's a complete humanoid robot that can walk, balance, lift heavy objects, and perform complex tasks. When you combine brain control with a full robotic body, you get something truly incredible. Now, before we move forward to talk about other exceptional updates to the Tesla Optimus, if you are interested in watching which two other robots match the class of Tesla Optimus in terms of innovation, then make sure to watch the video on your screen. But Musk didn't stop there. Just recently, he revealed another massive update. Optimus is now running Grok, a powerful AI voice assistant. This means the robot doesn't just take commands from thoughts, it can have actual conversations. Imagine walking into your living room and saying, "Optimus, grab that wrench and bring it to me." Instead of just following the command blindly, Optimus could respond with, "Which wrench? The small one or the large one?" That back and forth conversation changes everything. Before this, robots could only follow pre-programmed instructions. Now they can understand context, ask questions, and even handle changes mid-task. If you say, "Actually, never mind the wrench, bring me a screwdriver instead," Optimus can adapt instantly. This isn't just about convenience, it's about creating robots that think and communicate like humans. Grok doesn't just convert speech to text commands, it understands meaning, context, and even humour. It knows when you're joking and when you're being serious. For people with paralysis or mobility issues, this technology is life-changing. Imagine someone who hasn't walked in years suddenly being able to control a robotic body with their thoughts. They could attend family gatherings, go to work, or even dance at their wedding through a robot. This isn't about replacing human bodies, it's about giving people new ways to interact with the world when their biology fails them. An elderly person who can't lift heavy objects anymore could control robotic arms to help with daily tasks. Someone with limited mobility could use a robotic body to climb stairs or reach high shelves. The emotional impact is huge too. Alex wasn't just moving a robotic hand, he was creating, expressing himself, and connecting with the world in ways he thought were lost forever. That's not just technology, that's human dignity restored. While Musk was making headlines with brain-controlled robots, other countries weren't sitting still. China just revealed some shocking developments that are making the entire tech world nervous. First, they unveiled robot soccer tournaments where fully autonomous humanoid robots play complete games without any human control. These aren't remote-controlled toys. They're AI-powered robots that can run, kick, pass, and make split-second decisions just like human players. But that's not the scary part. China also revealed mosquito-sized robot drones that can fly undetected into buildings. These tiny machines can record video, capture audio, and even interfere with electronics. They're so small they could slip through window screens without anyone noticing. Even more concerning, China now leads the world in robotics patents. They're not just building robots, they're claiming legal ownership of the key technologies that everyone else will need to build their own robots. It's like owning the patents for wheels and then charging everyone else to use them. Not to be outdone, Google just announced their own breakthrough called Gemini Robotics. This new AI system can run entirely on a robot's hardware without needing internet connection. The robot can see, understand, and act all by itself. The impressive part? Google's system can learn new tasks with fewer than 100 demonstrations. Show a robot how to fold clothes 50 times and it masters the skill. This is a huge leap from the thousands of examples robots usually need. Google's approach focuses on making robots smarter at understanding what they see and translating that into physical actions. Combined with Tesla's brain control technology, we're seeing the building blocks of truly intelligent robots coming together. Tesla's breakthrough has forced every other robotics company to step up their game. At recent tech shows, companies like Neura Robotics revealed their latest humanoid robot, the 4NE1 Gen 3. This robot is designed specifically for real-world deployment in warehouses, factories, and even homes. What makes it special? Safety. The robot has force feedback sensors that let it work safely alongside humans. If it senses unexpected resistance, it stops immediately. It also has swappable hands and tools, making it adaptable to different tasks. Other companies are rushing to add voice control, better AI, and more human-like movement to their robots. The race is on to create the first truly general-purpose humanoid robot that regular people can afford and use. This technology isn't just for paralyzed patients or tech billionaires, it's coming to everyone. In a few years, the robots stocking grocery store shelves, cleaning hotel rooms, or assembling products in factories might be controlled by human minds. Imagine having a robot helper in your home that you can control with your thoughts when your hands are busy, or being able to attend important meetings through a robot when you can't travel. The possibilities are endless, but it also raises big questions. If your mind can control a robot body, where do you end and the machine begin? What happens when the technology becomes so advanced that the line between human and robot gets blurry? Think about your daily routine. You wake up and your brain-controlled robot is already making coffee because it sensed your thoughts as you were waking up. While you're in the shower, you think about what clothes you want to wear and your robot lays them out perfectly. During your commute, you control a robot at your office to start preparing for meetings before you even arrive. Parents could use these robots to help with childcare. While cooking dinner, you could control a robot to help your kids with homework in another room. Elderly people could maintain their independence longer by having robotic bodies that don't get tired or weak. A grandparent could play with grandchildren through a robot, even when they're too frail to visit in person. The job market will transform completely. A single skilled worker could control multiple robots in different locations. One surgeon could perform operations in 3 different hospitals at the same time. A teacher could give lessons to students around the world through robotic bodies. Construction workers could build skyscrapers while sitting safely in control rooms. The social implications are mind-blowing. Dating could involve controlling robots to meet people. Sports might become competitions between human-controlled robots rather than human athletes. Even family dinners could include relatives who are physically thousands of miles away but present through robotic bodies. Privacy becomes a huge concern too. If your thoughts can control machines, who has access to those thoughts? Could companies or governments monitor your brain signals? Could hackers take control of your robot body? These aren't just tech problems, they're questions that will reshape society itself. The economic impact will be massive. Countries with the best brain robot technology will dominate global markets. Workers who can't afford neural implants might find themselves unemployed. The gap between enhanced and non-enhanced humans could become the biggest divide in human history. What makes this moment so special is that we're not talking about distant future possibilities anymore. The technology exists today. Alex is already controlling robotic hands with his thoughts. Optimus is already having conversations with humans. The building blocks are in place. The next few years will determine who wins the global robotics race. Will it be Tesla with their brain-controlled robots? China with their massive patent portfolio? Google with their smart AI systems? Or will some other company surprise everyone? One thing is certain. Elon Musk just changed the game forever. By giving Optimus a brain and connecting it to human thoughts, he's opened a door that can never be closed. We're entering a new era where humans and robots don't just work together. They become extensions of each other. The future isn't about replacing humans with machines. It's about giving humans new ways to be human. And that future is starting right now.